Chapter 9, Section 4 is what we're going to talk about today, or at least pieces of it. We're not going to do all of the section, but this is going to be the last chapter, or last section that we cover in Chapter 9. A few of the things we're going to do, we're going to solve formulas for variables involving square roots. We're going to do some applied problems using the Pythagorean formula, and we're going to solve applied problems using area formulas. So a couple things within here that we are going to look at. So let's start out with solving formulas for variables involving squares and square roots. So essentially what we're going to do today with this objective is we're going to take and solve the equation for a given variable. So in this case, we're going to solve for r. So we're going to kind of isolate that r on one side of the equation and see what it equals, so that if we are trying to find r later on with something, that we could just kind of plug it into the formula and kind of have it work instead of manipulating the formula with numbers in it. So in this first example, we've got area is equal to pi r squared, which is the formula for the area of a circle. We're going to go ahead and solve this for r, meaning we want to isolate r. So when I'm isolating r, I kind of think about, okay, what would I do with all of the other stuff if they were kind of numbers? It's kind of what goes on in my head, and r was my only variable that was kind of sitting there. So I've got pi times r squared, so I've got pi times r squared, so I've got to isolate that r squared. So probably just for ease of purposes, we like to tend to have things on the left-hand side. I mean, I could just rewrite it like that. Don't have to do that, just whatever, it's just a step. But I've got pi times r squared, so if I divide both sides by pi, when I do that, I'm left with r squared, the pi's cancel each other out, is going to be a over pi. And now that you fell down, and I've written that already, let's bring you back up here and keep going. So we want to solve for r, and it tells us to plus or minus. So we've got r squared, so to get rid of square roots, to get rid of squaring, we do square roots. So we're going to do the square root of both sides. So we do the square root of both sides, so that leaves us with r is equal to, and remember earlier in this chapter, when we took square roots, we always put plus or minus. So that's plus or minus the square root of a over pi. Now, you could leave it like that. There's certainly nothing wrong with that. Some people might argue that now we've got a pi and we've got a radical in the denominator, because technically speaking, then, you know, this is equal to, I'm going to erase this and move it over to the side so it's a little bit further over. So we had r was equal to plus or minus the square root of a over pi. You know, some people are going to say, well, now you've got the square root of a over the square root of pi, so we've got that pi in the denominator, which we can't have. We've talked about that in the past. So that means I have to multiply by pi over pi. So that gives me the square root of a times pi over pi squared. That's just pi. And then you've got that plus or minus. So there's one way to do it. Either one of these answers is acceptable. It doesn't matter to me which one you have. Again, they're both good to go. We've solved for r. If I knew the area, I could go ahead and find the value of r now of that circle. So that's solving a formula for r being in there. And I think that's probably what they did. Okay, the next one asks us to solve for a. So it says s is equal to 30 times the square root of a divided by p. Okay, so we're asked to solve for a, so we've got to isolate just that a value right there. So I've got 30 times, so I'm going to multiply by 30 first. So that gives me 30s is equal to the square root of a over p. And I'm going to multiply, I'm going to square everything and get rid of that square root. So we're going to go ahead and square everything. So 30 squared is 900. So that's 900s squared equals, now all that's left there is a over p. We're solving for a, so I've got a divided by p, so I'm going to multiply both sides by p. So we've got 900s squared p is equal to a. And that's your solution, solving for a in there. Okay, just manipulating equations to solve for the variable that they ask to solve for. In this case, they asked us to solve for A. Okay, let's look at see what they did. Okay. We're good to go. Questions with that? Nope. This type of question, solving for t, something we're not going to do. That's too much. Okay, second objective then is to solve applied problems using the Pythagorean theorem. So let's look at a story problem. It says a ladder is leaning against a house. The distance from the bottom of the ladder to the house, when I'm doing these, when I'm doing applied problems, I kind of like to draw them. I'll read it first and then kind of draw. A ladder is leaning against a house. The distance from the bottom of the ladder is from the house is 5 feet. The distance from the top of the ladder to the ground is 1 foot less than the length of the ladder. How long is the ladder? Okay, so I've read it. Now I'm going to kind of draw it. So I've got a ladder leaning against a house. So there's my ladder. And I'm just going to label this L for now. Is leaning against a house. So here's my house, H. And here's my ground, G. And just kind of label them real quick. Since it's doing that, we know we've got a right angle sitting there. It says the distance from the bottom of the ladder, which is down here in the corner, to the house is 5 feet. So I can label that 5. It says the distance from the top of the ladder to the ground, so the distance of this is the distance from the top of the ladder to the ground, that's this distance right here, sorry. That's the top of the ladder down, not that green. So that's this distance right here. Is 1 foot less than the length of the ladder. The length of the ladder is right there, and we don't know the length of the ladder. So the length of our ladder is going to be our x value. So that's our x value. The distance from the top of the ladder to the ground is 1 less than the length of the ladder. So this is x minus 1. Okay, so there's what my ladder looks like. And now it asks us, how long is this ladder? Well, so we have to find x. Well, we know we've got a right triangle now, so we can go ahead and use the Pythagorean theorem to find our value of x. Remember, the Pythagorean theorem says that a squared plus b squared has to equal c squared, where a and b are the lengths of our legs and c is the hypotenuse. So a is x minus 1, so we got to go x minus 1 squared plus b squared, so plus 5 squared. That's got to be my hypotenuse squared, which is x squared. Okay, so now we've got x minus 1, and I'm going to go up here. X minus 1 squared is x minus 1 times x minus 1. So FOIL, that's x squared minus x plus 1. So combine like terms, that gives me x squared minus 2x plus 1. And then we've got plus 5 squared, so plus 25 equals x squared. Now we're going to solve this. So you notice we've got an x squared on both sides. So the x squareds are going to cancel each other out. So that leaves us with negative 2x plus 26 equals 0. Move the 26, so negative 2x equals negative 26. X is equal to 13. So the length of my ladder is 13. The height off the ground is 12. So we solved the applied problem using the Pythagorean theorem. I like to draw them. It helps me when I draw. I can see things a lot better when I can see them. Okay, so let's go through it again. Step 1, read the problem carefully. We did that. Step 2, assign the variable to the ladder. We did that. We're going to write the equation. So we did the Pythagorean theorem, a squared plus b squared equals c squared. Exactly what we had. Step 4, solve. 13, just like we got solved a little bit different than we did, but in the end we still got 13. Then you kind of answer the question. The ladder is 13 feet, 12 feet, and so on and so forth. And you're done. Okay, so that's applied problem using the Pythagorean theorem. Now let's solve an applied problem using the area formulas. So in this one, it says, suppose the pool is 20 feet by 40 feet. Okay, so if you see their drawing, they've messed the drawing up. That should be 40 feet. The homeowner wants to plant a strip of grass around the edge of the pool. There is enough seed to cover 700 square feet. How wide should the grass strip be? So our grass strip is kind of this green area on the drawing here. We know we want it to be uniform throughout. So that's why you see this length of X and this length of X. Okay, so then our pool is 40 by 20. Okay, this area, this length here is going to be the length of our pool plus 2X. X is on both sides. The length of this side is going to be 20 plus 2X. Okay. We have enough grass seed to cover 700 square feet. We want to figure out what it's going to be. Okay, so we've kind of got our drawing there. So step one, we've read the question. We've read the problem. Step two, assign variables. So the grass strip is what we assigned as our variables. Step three says write an equation. The width of the larger rectangle is 20 plus, again, typo error, 2X, and the length is 40 by 2X. So if we found the area of that, area is length times width. So if you think about it, we've got this length times the width. So when we write our equation, we have to multiply those two things together. But then we've got the area of the pool that's sitting in there already. So we're probably going to have to subtract that off because this area is bigger than the whole area of the pool. So we're going to have to subtract that off. And then we know what that area has to be. It has to be 700. Okay, so to solve this problem, we find the area of that rectangle. We have to subtract off the area of the pool, and we know we've got 700 square feet of grass that we can cover. So now we need to solve this. So we go ahead and use the distributive property, and I'm just going to let them do it for us. So step 4, solve it. Use the distributive property. So FOIL, so 800 plus 120x plus x squared. That's that part there. Minus 800 is going to be 700. I'm going to move some things around. The 800s here cancel each other out.
Sorry, I'm having trouble hearing you.
Now we've got 4x, and then move the 700 over. So 4x squared plus 120x minus 4. Now I think a 4 goes into both of those, so we can take a 4 out. So we just factored a 4 out. And now this can be factored using the factor tree, and we'll just show you how they do it. And a lot of times that's what's going to happen with this. It's going to be factored. So then we solve this. So x can either be negative 35 or x can be 5. It doesn't make sense for it to be negative 35, so the length of our side then is going to be 5 feet wide. Okay. So that's an applied problem with area. Again, make sure you could check it if you want and do all of that, but that is, in the end, what the solution is going to be. And remember, finding area of a rectangle is length times width, a square, length times width, and all of those different types of things, okay? And we're not going to do this. Oh, yeah, we are. Hang on. We are going to do it. I did decide that we needed to do these. So the last thing that we're going to talk about then, talks about projectiles, and this is a lot of physics stuff. And the nice thing about this is the formula is already going to be given to you. So it says a ball is projected upward from the ground. Its distance in feet from the ground is t seconds and is defined by the function s of t is equal to negative 16t squared plus 64t, where t is how long is its time that it's in the air. It says, what time will the ball be 32 feet from the ground? Okay, so we have this ball that's being thrown like this. Okay, when it lands, this ball lands. Okay, so we're throwing it, it's going like this. This distance right here is going to be 32. We want to know what the t value is in order to solve this. So what we're going to do with this problem is this s of t right here, that equals our distance in feet after t amounts of seconds. So we can substitute this s of t with 32. So 32 is going to equal negative 16t squared plus 64t. Now, if you notice, we've got a quadratic. Okay, so since we've got a quadratic, we have to set it equal to 0. So negative 16t squared plus 64t minus 32. That's going to equal 0. Okay, and then we're going to kind of, because I ran out of room, we'll let them do it. Okay, so that's just what we had. They moved the 16t over and switched the sign, which is fine. Factor out a 16, and you end out with t squared minus 4t plus 2 equals 0. So we've got this equation now sitting here that I'm covering up. Now we have to solve that. So that's going to be our next step, is to solve that. You can try to factor it. If it factors, great. If it doesn't, you've got to use the quadratic formula. So we're going to have to use the quadratic formula for this. So we had x squared minus 4x plus 2 was our formula that we came up with after we simplified it. There's our a value, b value, and c value, and use the quadratic formula to solve it. So plugged in, it's negative b, negative of negative b, so negative of negative 4, plus or minus the square root of negative 4 squared minus 4 times a times c, all divided by 2a. Now we're going to break out the handy-dandy calculator, figure out what we have underneath the square root. So we've got 4 plus or minus the square root of 16 minus 8 over 2. Square root of 16 minus 8 is the square root of 8. So that's 4 plus or minus the square root of 8 over 2. Now the square root of 8 can be simplified to 2 radical 2. So we've done that. Now 2 goes into everything. So 2 goes into 4 twice. So, and 2's cancel out. So we've got 2 plus or minus the square root of 2. So the time that it's going to be is either 2 plus the square root of 2 or 2 minus the square root of 2. So approximately 3.4 or 0.6 seconds is what it's going to be in the air. So the ball at a height of 32 is at about 0.6 seconds and 0.4 seconds. Okay, and you're done with that question. Okay. And we're not going to do this one. Okay. So those are all the different things that you have to look at in the last section, in section 9.4. I think the assignment today was maybe 6 or 7 questions. It was pretty short, I believe. Finish up that section 9.4, and then you'll be done for the week, and you get to, I think we have a 4-day break here coming up. So we'll start chapter 10 next time. Bye, everybody.